In this video, we're going to talk about the scientific method. The scientific method is really key. You probably use the scientific method all the time, maybe, and you don't even realize it. So the first thing you do is you observe something. Anything you want to do, you just observe it. You're like, oh, I wonder what makes the sky blue. Or my husband, actually, we went on a roller coaster, and we observed that the wait time was 90 minutes. And we were like, I wonder if the wait time is actually 90 minutes. And so we formulated a question. So this was our observation. And our question was, is the wait actually 90 minutes? And because we're really nerdy, we literally stood, we didn't do any background data, we didn't have smartphones at the time, but this is where you would check and see if anyone else has done your experiment. Experiments are expensive and they take a lot of time. So if someone has already answered your question, then you don't have to worry about doing an experiment. And you can go think of another question and start working on that. So this is where scientists research and collect data to kind of save them some money. And also they can see if anyone's done anything similar. And then if someone's done something similar, that can kind of guide their hypothesis. And so you can have two hypotheses. You don't have to have an if-then statement. I know in middle school they teach you guys the if-then statement, and you don't have to do that. So our hypothesis was that the wait is not 90 minutes. Okay, so then we decided to observe and collect data. This is your experiment. This is the fun part of science. This is where you get to do the experiment. This is where we actually waited in line and rode the roller coaster. And we actually, you want to do an experiment more than one time, or you want to have a couple trials when you do it, usually at least 3, but sometimes even more. And so we actually stood in line for 3 times, and we collected data each time and calculated, measured the wait time, and then at the end we drew conclusions. And I think we had something like 85, 92, and maybe like 76. It was something like that. And so we can see that if you were to average those or whatever, you could see that the wait time wasn't actually 90 minutes. They may round up a little bit. Okay, so that was okay. Now, if our wait time was 90 minutes, then it's not bad if we had shown that the wait time actually was 90 minutes. Okay, if our hypothesis was incorrect, okay, that doesn't make our experiment worthless. It actually gives us some useful data that they're actually doing what they're supposed to do. And you can make a new hypothesis based on what you've learned and continue. So this can actually be a continuum. You can go back and start over again. Just because your hypothesis was wrong does not mean your experiment was a failure. You still learned things. So this is really key with the scientific method. Now, scientific laws and theories. Now, in outside of science, lay people, a theory is like, oh, I have a theory that it will rain today, or I have a theory that it's going to take me 20 minutes to get home. And a theory is just kind of like a guess. In science, a theory is not a guess. Okay, we just don't call every guess that we have a theory. We call those hypotheses. Okay, a theory in science is an explanation based on many observations. And it says supported by experimental results, but a lot of theories, you can't actually support them by experimental results, so they can never be proved. And so that's why they call them a theory. For example, the theory of evolution. Evolution occurs on many, many year timescales, and it's very, very difficult to actually, you can't prove evolution because you can't have an experiment that takes that long. People die, many people die. in the time period it takes evolution to occur. And so, excuse me. And so we just call this the theory of evolution. Okay, that dinosaurs were hit by a meteor. That's another theory. Okay, we can't actually go back and prove that the dinosaurs were hit by a meteor. And so instead, we have a lot of data that scientists have collected from digs and things like that. And these are well supported. There's a lot of data behind them, and we call them a theory. As the data changes, our theory can change. Once you make a theory, that doesn't mean that theory is going to stay that way forever. You can always change it. And a scientific law is a rule of nature that sums up related observations. And this one usually does have experiments. Okay, the law of gravity. You can test gravity. Okay, the law of definite proportions, or the law of conservation of energy. All these things you can test. And so these are called laws because you actually can prove them. Okay, so this is the difference between a law and a theory. So let's think about whether these are a law or a theory. I kind of went over these, but let's see how well you were listening. Dinosaurs were killed by a meteor. Okay, we can't test this. Therefore, it must be a theory. Okay, gravity exists. We can test gravity. Okay, you can drop a pencil as much as you want. We can test this. So it is a law. Okay, so these are kind of two different examples of things that could be a law or a theory.